I didn't eat. Just basically my son's.
That's cool. You gotta be stressed
You
out.
say you didn't eat?
Yeah, you got to wake up.
I had Chick-fil-A
Did a
fries.
marathon yesterday. I was just doing what I can. I was like,
I had Chick-fil-A fries and a glass of wine.
Hell yeah. I just,
Not working hard. Fries and wine. Okay.
I just like, I was playing Dark Souls. And I went to work.
Fries and vodka.
maybe we'll do better.
Fries and vodka. Get out.
because,
Physics?
when I was done, I was like, yeah, like that.
All right, guys.
Can't turn.
Got your attention.
It
So
really
yeah,
depends for your
there are a
physics
couple of here that
It
you
really
gotta.
depends what
Sorry.
professor you have, because one professor will go one route, and the other professor will go a different route. Like,
I
Hello.
don't know if I have. I forgot.
There are a couple of here
my
you gotta
professor
actually think about
went most
that we didn't talk about yet.
about electricity.
It's not a
and
graded
physics.
thing, so I don't care.
It's pretty hard.
All right.
But you learn
I just want to see what you guys
which is
consider for like the idea of independent, like the shit with that mean. We're going to talk about it. It's not the most obvious thing in the world, but when you see it, it's like, oh
the
yeah.
magnetic field
Um,
towards you.
So the very first thing you should do, obviously, is add all these up. So let's see if Jeff can do that. No pressure, Jeff. Is that 126? 50. So 176. Yay. Okay. So one student is selected at random from the group above. What's probably they attend Grossmont? Yeah, 126 to 10 Grossmont out of 176, whatever you got as a decimal. This is the work. Remember what shirt I wore yesterday? So if you do these kind of problems and you don't do that and you get the wrong answer, I assume the worst and all the points come off. You've got to show me the work. And the work is setting up that ratio. I like it. For a basic probability question. Where'd you guys get for the percentage?
71.59.
71.59? And something else that people, this is a separate problem, right? This is part B. Some people kind of take it as if it's adding on to this. No. How many are business majors?
92.
92. Out of 176, which is
52.27.
52.27.
27.
Why are you doing that? Okay, weird. And then is a computer science major or attends Grossmont. So if I do all the Grossmont people, 126, I can then add in the computer science people I didn't do yet. I know a lot of you guys did 126 plus 73 minus 62, but 73 minus 62 is freaking 11. Right? Out of 176, 137 out of 176 is 37.8.
So which way did we do it?
We did it a different way.
Whoa, there
But
it
it's
is.
the same thing.
Okay, so we did it 73 plus.
We did
How are we doing so far? Is that-
36 minus 62.
We haven't gotten too weird yet, so this is where people really start to get confused. If you try to use a formula here, you almost will guarantee to be wrong. The formula will work here, but the formula is gross. You have to do the probability math major times the probability Cuimaca given their math major. That's a lot of freaking work. Why don't you just count how many students do both? How many students do both? 2. Out of how many? There you go, see?
1.14.
Just to remind you guys, I do videotape these lectures and put them up on YouTube. There are some people trying to take pictures. These are up on the YouTubes, on the internet. The internet is a series of 2. What is 2 out of 176, sorry? 1.14. All right, now here's the first place. The only place where the bottom does not start off as 176 is when I give you information. So given their computer science major, so what's going to be on the bottom?
73.
73. 72 computer science majors. Out of those, how many are Grossmont students? 62. What's that? 84.93. Okay. Now, a question about independence of two things has to include some intermingling of the two things. You can't say well, the probability of a Grossman student is this, and the probability of a computer science major is this, and they're not the same. That doesn't make any sense. Those are two separate things. You have to see how one affects the other one. If one does affect the other one, they're not independent. They're dependent. If they don't affect each other, they're independent. So, what's the probability that I have a Grossman student, period?
71.59.
71.59. There's another probability of Grossman student question up here. Right there. What's the probability that they're a Grossman student given the other information that they're a computer science major? 84.93. So, knowing that they're a computer science major, does it change the probability they're a Grossman student? Yes. So they're dependent. It depends on if they're a computer science major or not. It will change if they are.
For all the questions like that we show up with, we just write, like, well, on that, like, I just write, like, no. And I write it, like, the probability of, like,
Yes.
if a G given S is not equal to 1.
Yes.
Okay.
This is more of a math answer. If you try to write a paragraph about something,
Good.
99% going to be wrong. So this is, how do I test to see if two things are
Did it
independent?
right?
If the
Well, this
probability of A
Go back.
equals the probability of A given B, then A and B are independent. Think about what that means. If B happens and A doesn't give a shit, if two people are independent, that means the one does something and the other one doesn't give a shit. So if B happens, given that B happened, and A doesn't care, how does A show it doesn't care? Its probability stays the same. Oh, you did that? That's nice. If that was true, they would be independent. Here, is it true? No. The probability of G given CS, I like it. Yeah, so far. Probability of G given CS. Probably Grossman student given computer science. Is that equal to the probability of Grossman student? No. Oh, good Lord. 84.93 does not equal to 71.59. So, dependent. Yes, sir.
On our test or something, do you want us to list, like, a key for what our, like, events are labeled as in that case?
Put that this
Or,
way.
like, is it kind of, like, I use, like, probability of G given S for science. because
Yeah.
G
Oh, I
was
see.
NACA.
You're fine. I can work out what it is. If you give me tables, even better.
Because that's what we did right here.
Does everybody see that? You can't say, well, the probability of flipping a coin and getting heads is 50%. The probability of getting an odd number on a die is 50%, so therefore they're dependent. No. That's two separate. You got to see how they affect each other. Right? Given that one happened, does it change the other one? That's why we call it dependent or independent. What's probably the gross one? Well, it depends on if they're computer science major. If they are, it's a higher probability. The thing that people get confused about is, it's not that I can't be a Grossman student unless I'm computer science. That's not what it means. People say, you could be a Grossman student without being a computer science. No, that has nothing to do with the question. The question is the probability change at all. So an example would be, and this always leads to a little bit of controversy, and I don't care. If you see somebody walking towards you way off in the distance, you can just tell it's a person. What's the probability it's a man?
50.
50%. I like it, right? 50% chance it's a man. I can't tell. Nothing to say about the dude. I just can't tell if it's a dude or not. If I saw that person get off a Harley, given that they got off a Harley Davidson motorcycle, is the probability they're a man still 50%?
Yeah.
No. Now, I love it when women all get, some women ride. I didn't say they don't. But who rides them more often?
Men.
Men. So if I see the person get off a Harley Davidson motorcycle, the probability they're a dude has definitely gone up. Not to 100% This is where people get confused. Probabilities don't mean definitely yes or definitely no unless it's 0 or 100. Did the probability go up that it's a dude? Hell yes. Right? They'll probably get an A on a test. Does it have anything to do with the number of beers you had the night before? A little bit, right? Right? So those are dependent events. Okay, I like it.
Me.
In fact, we're going to do correlation studies between that. Well, not really an experiment. We just
Oh,
go on
darn.
record. I am not asking them to drink the night before and then take a test. All right.
We could.
We will do a thought experiment. Some of you guys maybe will do your own experiment. Maybe you've already done that yesterday or something. I don't know.
That's how I got an A. I'm just
Sunday
kidding.
night celebratory. I don't know. Anyway, all right.
Get drunk and study.
Moving on. So this is a really good note here.
So they're not
This is the only thing that will answer this question. You can't reason it out. You can't talk about it. It is a mathematical definition.
So
Two things are only independent if knowing one doesn't change the probability of the other one. That's the only way they're independent. Yes, sir. Sure. Right here. I mean, if B happens, and the probability of A does not change, do you see that? If the
that's
probability of
why I
A
test.
is the same
That's why I
after
test.
B happened, if it doesn't change,
The probability of
then A doesn't care that B happened. I would call that independent, wouldn't I? Just naturally, that's what I would call it. So thank God math people went, let's do something that makes sense for one. Right? So they call it independent. If they do change like it did here, given their computer science major, the probability went up that they're a gross fund student, dependent. Because knowing one happened changes the probability of the other one. So hopeful.
So that's what we read on the test.
What's that? If you write, no, don't worry about that. That's
Okay.
the note. That's the explanation of what to look for. You do this work, you're golden.
Okay.
And guess what I'm going to do? You notice how I made you do some of the work in part A, and I made you do some of the work already in part E. I always put in your work what you need to answer this question. You just have to go find it. Will it always be part A and part E? No. Okay, maybe. Yes, ma'am? That's it. Since they're not equal to each other, since one happening does change the probability of the other one, then they are dependent. Okay. That's the first little thing that I just left you on your own for a minute. You guys freaked out a little bit. All right, number 2. I like this. Lock them in a haunted house, and we're like, just leave in there, shit. You pick this first part. Hopefully, this wasn't too bad. You pick one person. What's probably their Democrat? 7 out of 21. Yeah, 33.33%. I like it. 3. Now, if you put a little line over the 3 out, that's beautiful, right? I say round it to 4 places, but if you are more precise in some areas, I am not going to knock being more precise. With it? Just don't give me 16 places on something crazy. Probably the Republican, 12 out of 21, which is
7.14.
14. All right. So now we go to 2 people. This is going to be like what I call the hangman game. You have 2 spots to fill in. 2 spots. One person and another person. We select an independent. Okay, what's probably that happening?
2 over 21.
Yeah, 2 out of 21. And we put that person back in. And then a Republican,
12 over 21.
12 out of 21. When you multiply those together,
5.4.
5.44? Yeah. Okay. 2 Democrats. Another way to say that is we select a Democrat and then another Democrat. Right? If you want to put it in the same format. So one person, another person, probably the Democrats.
7.
7 out of 21. 7 out of 21. 11 point?
11.
11? I like it. Yeah, 1/3, 1/3, 1/9, 11%. I like it. Okay. Real quick, you guys know that 1/3 is 0.3333 forever?
Yeah.
So 1/3 of that, if you take 0.33 forever, divide by 3, you get 0.111 forever. So 1/9 is 0.111 forever. So 4/9 is 0.444 forever. 8/9 is 0.888 forever. No? You guys like, we got these things called calculators? Oh shit. All right. All right, now I do it without replacement, and I do this all the time. I do the same question. So you can basically base it off of what you already did. I haven't done anything yet, so the independent happening is still a 2 out of 21 chance, but now what's probably the Republican happens?
12 out of 20.
Well, Republicans still in there out of 20 people, because I let the first guy leave. He's like, give me that light. And whatever the hell that is.
5.7.
5.7?
4.
7-1? 7-4?
7-1.
4.
7-1-4.
Jesus Christ.
1-4.
And then the two Democrats, the first one is still a 7 out of 21, but now I let him leave.
Adios.
6 Democrats left out of 20 people left.
4 out of 420.
10%.
42 out of 420. What the?
The sun has come out. I control the sun.
Spider-Man 2.
The sun away.
What's legit?
All right. That was your favorite one. Favorite. So this is a lot like the O-ring problem. Now here's something interesting. I really want this to make sense. On part E and F, I had to show the ratios and I had to show the bottom becoming less and all that kind of stuff, right? How many Americans are there running around?
Billion. We don't know.
Huh?
Billion.
340 million, I think maybe it is now. I still remember when
That's
it clicked over to 300 million,
Not
but
everyone's American.
no. Americans, not people.
Okay.
There's like
Not everyone's American.
8 billion people on the earth now or
I
something.
was counting the world.
7.5.
Yeah, I was
7.5
like 7 billion.
I like it. Some of you guys are like, you're
Not-
way ahead of yourself. We haven't taken everything over yet. And I don't think we will. So probably better.
All we got left is Antarctica.
Guys, everybody, I love it. Everybody's broken off talking about something. Come back to me. So there are 340 million roughly American. We can look it up on Google, whatever. It's roughly right. So if I did write a ratio, it wouldn't be like 9 out of 100. It would be whatever out of 340 million. But if I change the bottom to 339,998,999, that's not going to change the probability at all. So when you're talking about a large population, you can just leave the probabilities alone. You don't have to do like we did in part E and F. You don't have to change them because they basically stay the same. If I change the bottom by 1 and you got 340 million down there, it's not going to do shit to your number. It's going to stay the same fundamentally. So it becomes like the O-ring problem we did. We had 3 O-rings, and I wanted them all to fail, so I just put the probability of each one failing in and multiplied them because it's an and. So I want the first one to view them favorably, so it's probably somebody views them favorably, 0.09. And I want the last 3 to not view them favorably, so it's probably somebody who does not view them favorably.
0.91.
The rest, 91, so 0.91, 0.91. Some of you guys might realize you can write that as 0.09 times 0.91 to the third power. And this is going to even be the first power here, right? I have 1 like and 3 don't like. That's how you can kind of interpret that in English. It's crazy. And now you just throw that in the old calculator. What do you guys get?
6.782.
6.782. Okay. Sounds familiar?
I'm doing 04.
All right. We don't have to break off to a North Korea discussion again. The gang solves North Korea problem. There you go.
I don't get it.
It's always sunny.
It's always sunny. Anyway. Now watch. Here's where things get interesting. And you're like, finally? Okay, now watch. Ooh, you guys are gonna love this shit. Okay. At least 1 is such an evil, it sounds so simple. But what does at least 1 mean? So if I have 4 people I'm talking to, how many of them could, what was the question? View them favorably. How many of them could?
4
All 4, sure.
or 3 or 2 or 1 or none.
Yeah, so I could have one of them, none of them, or one of them, or two of them, or three of them, or four of them. Right? Are you guys with me? Yeah. If I have four people, how many could do something? None up to four. Makes sense. If five of them did, I'm like, what? Okay. If I add all these up, of course I'm going to get what? If these are all the probabilities and I add them all up, I get 1. Everybody cool with that? Of course we do. If I add up all the probabilities in a situation, it's got to equal 1 or I left somebody out. Now, at least 1 sucks so bad in general, but here especially. What does at least 1 mean? It means 1, and how many ways is there to have one person? It could be the first person, or the second person, or the third person, or the fourth person. So you got to calculate those probabilities, add them all up. Or it could be 2 people. The first 2 people, the last 2 people, the middle 2 people, the first person, the last person. Holy shit, I don't want to do all that. So what part of this side is the question? At least 1.
0.
What part of this side is related to the question? What's at least 1 up here? 1, 2, 3, 4 is at least 1, isn't it, please?
0.
Please, yes?
Yeah.
At least 1 is 1, 2, 3, 4, because we got 4 people. Okay, so if I calculated this, that would be the answer. But you guys see how there's another way to do this? There's so many ways to do this, but I'm not done yet. There's so many ways to do this, but I'm not done yet. Holy shit. I'd rather do this and subtract it from 1. The probability of at least 1 is 1 minus probability of none. Always. What's the opposite of at least 1? None. If I said at least 1 person in here likes lima beans, what's the way you can show me I'm wrong? The only way you can show me I'm wrong is that you show me that nobody likes lima beans. So the opposite of at least 1 is none. And how do opposite probabilities relate? 1 is 1 minus the other one. It's probably gonna, if the probability is going to rain today is 90%, it's not going to rain.
10%.
Yeah, we know this. We intuitively know this already. It's got to hold no matter what. If I got this situation and the opposite situation is easier, shit, yeah, I'm doing the opposite situation, doing minus 1. And then I'm going to answer the question, or 1 minus that. So how do I do the probability that none of them view North Korea favorably? So I want the first person to not like them, and the next person, and the next person, and the next person. They're all going to be what?
0.91.
0.91. This one doesn't view them favorably, right? I want none of them to view North Korea favorably. 0.91, so it's 0.91 to the
4.
4 people to not like them, right? Whatever that is, you do 1 minus that. So if you do this, you got the opposite of what I want. So how do you get what I want? 1 minus that shit. Yes? Oh, you're good? Stretching? Stretching always gets me. Look at you doing it again. Jeez. Now I'm going to start doing the back shirt. Yeah, just get ready for later. What is... Sorry, yes.
So is the formula 1 minus PO
Huh? In this case, the probability of at least 1. What's the opposite of that? None.
Oh, so that was just for the example, that's not like the actual equation?
So this is true if you have a situation where it could be 0 up to some number.
Oh,
Is every situation like that? No.
so it only applies if it says at least 1, or at least just...
And you have a situation where you're counting things. Yeah, 0, 1, 2, 3. Yeah. What is the more general idea? The probability of something is 1 minus the opposite of that thing. And this book uses a different symbol. I use this to be not. So the probability of not A is 1 minus the probability of A. The probability it ain't going to snow is 1 minus probability it is going to snow. Right? We know that. We knew that coming in. It's just so easy to not realize that's really what we're talking about. Same shit. So what is 0.91 to the 4th power? Oh. Who?
16857.
6857? So then 1 minus 0.6857.
31.43%.
3143, yeah. Yes.
So, in general, I try to like use it. So that's like use
Yes.
the real world more. Is like the A bar or the A prime more commonly used, or are they both used, or
The bar is more commonly used.
why does the book use A prime then?
I don't know. It's just the authors liked it themselves better. Yeah. Again, with notation, there's a lot of leeway. Yeah. When I teach calculus, I show my students a different way to write something that my colleagues don't agree with me with, and I don't give a shit. But it's just a way to represent something, so it almost doesn't matter. What's the right way to refer to a table? Well, we use the word table. Yeah, mesa, right? Well, what's the right way to refer to a box? Alcohol. Oh, okay. All right. All right. Isn't that alcohol in the box?
Yeah.
All right. Yes.
Is this for number?
This is a box.
3B. Yes. Yes. Let me write it on there and make it all official.
Make it all official.
So you guys realize that it doesn't matter if I'm on the whiteboard or the paper.
So if you, at least, they're the one, well, I was right. They're the ones that view them,
I forgot my chapstick.
Hold on.
It's a bad day. I forgot my chapstick. Oh wait, no, I didn't.
So what is the chances?
Happened to me.
What's the chances that if you take 4 randomly selected Americans, that at least one of them have a favorable view of North Korea? You have a 31.43% chance of that happening.
how comes that? 25.
Why would it be 25?
So 1 out of 4.
That doesn't make any sense. That's assuming everything's equal. I have a 9% chance somebody has a favorable view of North Korea. You didn't use that information anywhere in that problem, anywhere in your work. So the way you looked at it, it doesn't matter what the probability of a favorable view of North Korea is. It would always be 1 out of 4. That doesn't make any sense. Does that make sense? I mean, this doesn't say the probability of 1 person out of 4 doing something. This says at least 1. Plus, you have to use the information you know. It has to depend on the chances that somebody likes North Korea in the first place. That has to be in the problem somewhere. If not, then it doesn't matter if it's 9% or 87% like it. It wouldn't matter. Then that doesn't make any sense. Maybe. Okay. This kind of thing, it's interesting when you look at like false positives from a test. You know, you can talk about the big bad, the HIV test, and if they say it's positive, the chances it's false positive are higher than anybody thinks. So that's why you want to do follow-up tests and so forth, right? So if you ever get a positive back on some kind of result from a lab, don't immediately freak the hell out, because false positive rates are always so much higher than people think.
It's a food baby.
Oh, what else to tell you? Isn't that number higher than you might think?
Yeah.
Only 9% of people like North Korea, but I got a 31.43% chance of getting at least one like in North Korea. Is higher than we thought. It's kind of related to false positives and how likely they are. It's more likely than most people think. Okay. So what about that? Now that last problem, I love it. This is the one problem on this test you definitely have to give yourself symbols to work with. All right, so we know the probability. How do you want to reference the 9%? What symbol do you guys want to use to reference the 9% favorable view of North Korea? Yes.
Then.
There was some of the trick questions that maybe I just didn't realize. It asks if both given that like Brussels sprouts. So this is, if we also know that 60 Americans have favorable view of North Korea and Brussels sprouts, find the possibility that an American likes Brussels sprouts, even if they like North Korea, isn't it 6%?
No.
But it just says that
Brussels
60% of
sprouts.
Americans have
I love Brussels sprouts.
True.
With some bacon. With
Which
some
is not a
vinaigrette,
given. It's an and.
Some Parmesan cheese.
They're related, but they're not the same. Yes.
Can I go back to 3B real quick? When it's 1 minus the 0.657, and then you get the 0.3, do you still have to multiply that by 100 to get the percentage?
Oh, sure. Yeah, you just move the decimal twice.
Okay, just wanted to.
So yeah. real quick, and of course it's move it twice because it's spaced out of 100.
Yeah, I just
And I always
don't
tell people decimal, percent, put it in alphabetical order. And if you want to go from decimal to percent, you move the twice that way. If you want to go from percent to decimal, you can move it twice that way. Hopefully most of you guys don't have a big trouble with that. Okay.
They're 13 letters away.
So,
DV,
again, how do you want to represent a favorable view of North Korea? I would probably just use
N.
F. That's great.
He's a math.
Right? You guys understand what I'm trying to say? I'm going to represent that with P of F. Probably a favorable view. That makes sense. You could also use N for whatever, but that doesn't make as much sense. That is 0.09. Now, how do you want to represent this then? Favorable view, we know, so what's 6%? It's probably a favorable view and
B.
Brussels sprouts. They like Brussels sprouts. So how do you want to represent Brussels sprouts?
B.
I like. You have to know. Use S for sprouts. You can use Y for yucky if you don't like it. Doesn't matter what letter you use. Now, what's the question that I'm asking?
Is that an American?
Those are the two things we know. I've written symbols for the two things that I know. Do you notice how slowly I'm talking now? Because this is related to a couple of homework questions. Oh, shit. They don't talk about North Korean Brussels sprouts. But they do talk about things, and you have to give them symbols so you can use the stuff in an equation. So what is it that I'm asking for? What's the symbols for what I'm asking for?
Probability of B given F.
Yeah, probably they like Brussels sprouts, given they like North Korea. So what's the formula for that then? We know that from the formula stuff that we did earlier. Probably
F and B.
F and B.
Probability of F.
over the probability of the given. Isn't that exactly what we know? So I wrote symbols for what I knew, I wrote symbols for what the question was, and I wrote the equation for what the question was. So now I can see where the shit to put things. So what's, yes?
What's the name for the vertical bar, like for given?
He's 66.66.
Is there a name for it?
The bar. The vert. We'll call it the vert.
6.67,
How's
I
that?
guess.
Yes? No? I don't care. So this will be 0.06 over 0.09. You just got to throw that shit in there, right? So people get so lost, and I don't like to teach this way, but once you get through all my definitions and derivations, when I ask you a question, you can write the formula for what the question, what represents that answer, right? And then you can say, what do I not know yet? Or what do I know, and where's it go? It's crazy. So yeah, it's 0.06 over 0.09, 6 ninths, 2/3, 66.7. %, chance that they like Brussels sprouts, given that they like North Korea. I love it. Now, is that real? No. I mean, I just made a silly thing. But, okay. All right. Ooh, we survived that. You guys want to look at the back for a second? What time is it? Oh, cool. I wanted to let us out a little early. Yes.
On the backside,
Yes.
is that a trick question or
You mean 2B?
2B. It's not a trick question. It's just, if I only have one Butterfinger, and the question's asking what's probably get 2 Butterfingers and something else, yeah, unless it's with replacement, the first one you could do. Yeah, so it's not trick, it's just realizing. Yeah.
For something like that, you want us to show work, should we just put the answer?
Yeah, you can just put the answer. Yeah. That one's a little straightforward.
Since we're talking about that one, I just want to make sure that I'm thinking about everything. So the probability of you choosing the Butterfinger would be 1 out of 13 to begin with.
Yeah, yeah.
Since there's only one, the next probability would be 0 as well.
Yes.
For the third one,
That's where things get theoretically weird. That's why you don't worry about it, because it's 0 anyway. The minute that one of them isn't possible, the next thing gets weird. Of course it does, because that middle thing is impossible.
since you don't hold
I know.
it out,
but you pull it out with a probability of 0. So you can argue either way. Why does neither way matter? Because it's going to come out to be 0 no matter what.
Since you don't like.
I know. You're wondering about what the next denominator is? Okay. It's both and neither. It's like a Schrodinger's cat thing. How's that? No? No Schrodinger's cat? Yes? Rick and Morty episode. Some people get it there. Yes? So guys, wait. Guys, 4C? Ooh, yeah, I like that question. Haha. That's all I'm going to say about it right now. Yes?
Before that one, I just calculated what it is and then saw that was next.
I don't care. No.
What's the smallest?
I didn't ask you to do that first. Yeah, theoretically. Shh. Don't say anything about it. I want people to have a chance to think about it. Yes, you do have to think. I'm not going to tell you every little thing. Holy shit. That's life.
That's true.
Like, this is college. Well, that's part of life. Sure. Okay. That's really all I had for today. So it's up to you. You guys have more questions, it's fine. I'm trying to let you guys out early. Normally, people work with me on that. I'm also trying to let myself out a little early, so hey. Tomorrow. Yeah.